Where is Jupiter's core? The largest gas giant in our solar system doesn't seem to have one. Our Juno spacecraft has been orbiting Jupiter for years now, and we've never found its core. We know that because Jupiter is a gas giant. It doesn't have a solid surface like Earth, but even planets made out of gases are still required to have a core. Scientists expected Jupiter's core to be around 20,000 kilometers in diameter. But what they found was really strange. Juno detected that the materials in Jupiter's deep interior don't seem to be well mixed, which suggests that there has never been a time when all of Jupiter's material was thoroughly blended together. And that means that its core may have formed separately and then got stuck inside the planet. So where could that core be? It's me, and you're watching this channel. Join with me today as we look at the surprising new discovery about Jupiter's missing core and how a huge collision may have created the giant planet we see today. If you haven't already, please consider subscribing to stay up to date with future videos. Gas giants are known to have cores, but exactly how big are these cores, and are they even necessary for a gas giant to exist? Well, before Juno went to Jupiter, scientists were pretty sure that beneath the clouds of our largest gas giant lay a core of rock and metal. The idea was that some of the material that made Jupiter had gotten so dense that it would collapse under its own gravity and form a solid center. The rest of the planet would then be made up of hydrogen and helium in various states, from gas to liquid to metallic. But since Juno arrived at Jupiter in 2016, scientists have been questioning whether their assumptions about the structure of the planet are correct. A paper published in June 2023 by researchers from the Southwest Research Institute in Texas presented the latest findings from Juno. According to their observations, the materials in Jupiter's interior do not appear to be well mixed. That means that there was never a time when all of Jupiter's material was thoroughly blended together. Instead, the materials seem to have assembled themselves into layers. This raises an important question. Where is the rocky or metallic core that scientists have been expecting to find? There are two possible answers to this question. First, Jupiter's core could be inside the planet, but it's just more diffuse than scientists predicted. Or second, Jupiter's core could be intact but separated from the rest of the planet's material. So what do these two options mean for how Jupiter formed? To answer that question, let's talk about how we know that Jupiter is even missing a core in the first place. Juno is equipped with several instruments designed to peer beneath Jupiter's clouds, including a device called a magnetometer, which measures magnetic fields. Magnetic fields are often used to probe planetary interiors because they provide clues about the matter inside a planet, such as its conductivity and overall composition. Juno's magnetometer revealed something strange, though it turns out that Jupiter's magnetic field isn't perfectly symmetrical. This suggests that its interior can't be perfectly symmetrical either. If Juno's measurements are correct, then Jupiter's inner layers must be divided somehow, like a layer cake. In fact, scientists have been able to use Juno's data to image the interior of Jupiter and see that it is stratified. The outer layer of the planet is about 70,000 kilometers thick and is made mostly of hydrogen and helium. This layer is in a supercritical state, meaning that it's not quite a liquid and not quite a gas, but somewhere in between. Beneath that is a layer about 20,000 kilometers thick that is metallic. That's probably because of the extreme pressure at that depth, which compresses the hydrogen so much that it behaves like a metal. And if we go deeper, we come to the mysterious boundary that lies about 95,000 kilometers below Jupiter's cloud tops. This is where Juno's data stops being reliable. So we don't know exactly what's in the deepest layer of Jupiter, or why it's different from everything else. But what does it mean for a planet to be missing a core? Well, scientists know that whatever is at the center of Jupiter isn't like the Earth's core, which is made of iron and nickel. If that's the case, then Earth's core must be floating in a sea of hydrogen and helium. Of course, that doesn't make any sense. But the only other option is that the core is actually part of the planet. In other words, Jupiter is actually missing an outer layer. This makes it seem as though Jupiter is missing a chunk that should be somewhere between 20,000 to 40,000 kilometers wide. But where could that missing piece be? Scientists have proposed that billions of years ago, Jupiter was struck by another planet-sized body. This impact would have blasted debris into space and left a giant crater in the planet. Over time, the material from the impact could have settled back down onto Jupiter, forming a shell instead of a core. But if this is true, then why hasn't the planet's shape recovered? Scientists think it might have to do with the mysterious boundary that we found in Jupiter's interior. This boundary seems to prevent the material above it from mixing with the stuff below it. And if it's strong enough, it could also keep the planet from collapsing under its own gravity and regaining its original shape. But does this missing chunk theory actually explain how Jupiter formed? That's hard to say. Scientists will need to gather more data before they can say for sure. But there are some clues that fit nicely with the idea. For instance, computer simulations suggest that only a direct hit from another planet-sized body could explain the size of Jupiter's current coreless cavity. Other models have tried to explain how Jupiter might have lost its core through other means, but those models require multiple collisions, or the influence of a nearby star. And there's no evidence that either of those things happened. Juno has been gathering data about Jupiter since arriving at the planet in 2016. And although it has indirectly detected the planet's core, the spacecraft did discover a bunch of other cool stuff. Like, did you know that Jupiter's clouds can survive 300 times the radiation that would kill a human? Juno found that, thanks to its onboard radiation sensors, radiation is usually bad news for organic molecules, like the ones that make life on Earth possible. So scientists were surprised to find that many of these molecules survived exposure to Jupiter's radiation belts. They're now thinking that the molecules might be protected by a layer of water ice, which is good news for any future explorers who want to visit the planet. Juno also found that Jupiter's winds blow faster than anything we've ever seen on Earth. The fastest wind speed recorded was 618 meters per second, which is about 2,200 kilometers per hour. These winds move heat around the planet and produce the beautiful bands of clouds that we see from Earth. But it's not just the weather that's wild on Jupiter. The planet's magnetic field is also crazy. It's so powerful that it extends 420,000 kilometers from Jupiter's center, far beyond the orbit of the Moon. And it's so intense that it deflects solar wind and creates its own auroras, which are almost 100 times brighter than Earth's. Juno will continue exploring Jupiter until at least 2025, and with any luck, we'll learn what happened to its core. In the meantime, scientists will be poring over the data they already have and running simulations to try to understand how Jupiter formed. Maybe one day soon we'll have a complete picture of the planet's history, but until then, the giant gas giant will continue to be a mystery. If you enjoyed this video, please subscribe to this channel to stay up to date with future videos. Thanks for watching.